Okay, students, right now I want to talk to you about Unit 5.6, which is on the topic of inverse function. Here we go. Unit 5-6, inverse functions and relations. Now, you may ask, well, what is inverse function or inverse relations? And I do want to say that oftentimes it is a function, and the inverse of that often turns out to be a relations. Now, it could still remain to be a function, but there are also cases where it becomes non-function, or we call it the relations. So that's the reason why we use those two terms and mixing them together depending on the situation. But what that means is, simply put, it's simply just that you take x and you replace it with y, and you take y and you replace it with x, and you reverse them. So in this case, let's just go right into it. Y is equal to x squared. And then the question is to find inverse of y function. Now you can say y is equal to x squared, or you can say f of x is equal to x squared. Doesn't really matter. Now the notation, right? Notation for inverse function oftentimes is y to the inverse function, or f of inverse of x. Now this is not the same as f of x to the negative 1 power. Actually, let me take away the parentheses. I think this is too confusing, so I'll take away the parentheses over here. But in any case, what you should see is oftentimes f to the negative 1 in between f and f of x, which is not the same, because if you have f of x to the whole thing to the negative 1, that's oftentimes means this, right? That oftentimes means 1 over f of x. That's not inverse. This is not inverse. This notation is inverse, though. So this is something that I just want to make a side note on this, just to make sure that you don't get confused later on. So take this for example. So now we have y is equal to x squared. I want to find inverse, so I switch x and y. So in this case it becomes, right? So it becomes x is equal to y squared. Okay? And then we solve for y. If you want to solve for y, right, you have y squared equal to x, so you square root on both sides, right? Remember, you want to square root on both sides. You square root on both sides of the equation. But what happens is that when you square the square root of the equation, you want to account for two answers, plus and minus. Got to be very, very careful with that. Whenever you're squaring root or square rooting both sides of equations, you end up with plus and minus, right? So y is equal to plus minus square root of x. Now you say, well, why is that? I mean, let me rewrite this just so that it's for ease of looking at it. Y is equal to two answers, square root of x and negative square root of x. Well, it's because, if you think about it, if I take negative square root of x squared, I end up with x, which is y squared, right? X is y squared. So negative square root of x can also give you y squared. square root of x squared is x is also y squared. So both answers can lead you back to the original function. Okay? No, I'm sorry, to the original inverse relations. Okay, so in this case, you have that. Okay, you have that. Now, often this is what you will see, and let me just kind of rewrite this in the context. Often you see this way: f of x is equal to x squared. Right? So inverse, this is inverse. Based on what we just did, we say inverse function is square root of x and negative square root of x. Now let's take a look at the graph, and I can show you on the calculator, but I can also show you just simply by sketching it out here, and you can verify on the graphing calculator if you like. So let's take a look at this. So let's take a look at the inverse. The inverse f of x with the square root of x is this graph. We know that, right? F inverse of x, we got square root of x. But the negative f square root of x is precisely this one on, right down below. It is also f of x, f of inverse x equal to negative square root of x. So that these two things put together, and as you can see, because you have the top and the bottom, it won't be able to pass the vertical line test. This is not a function together, but you can consider it as a relation patchwork of one function going to the top and one function going to the bottom. Now think about it. What is the original function f of x? Original function f of x is x squared, and x squared look like this. Well, look at this. Do you notice something? You notice that they look the same, at least shape-wise, but just the orientation of that parabola has changed. But here's an interesting thing. If you take a 45-degree angle line and you draw it across that, right? And this is what? This is y equal to x, right? This is a y equal to x line. Y equal to x line. This is a 45-degree line. And you can think of it this way. If you look at this line this way, let me just bring my camera down here so you can see. If this 45 angle line is basically a up and down line, you can think of it as the function and its inverse function is basically a mirror image along this y equal to x 45-degree line. You see that? This turns out to be true and is the defining property of function and its inverse relations. And we'll come back to this point in just a moment. Okay? We'll come back to this point in just a moment. So let's get practical and give you an example. F of x is equal to x plus 5. And I want to find inverse of f inverse function x. So very simple. Instead of writing f of x equal to 2x plus 5, I write y equal to 2x plus 5. And then I switch x and y. I write x for y and y for x. And then I solve for y. I solve for y. So it becomes x minus 5 is equal to 2y. Then y is equal to 1/2 x minus 5/2. So this is indeed my f inverse of x. So this is the inverse function of f right here. Now if you look at this function, it's very simple. We can actually simply graph this. When we graph this, we know that this is the y-intercept is at y equal to negative 5/2 or negative 2.5. And we know the slope is 1/2, which means it goes up 1 unit, goes over to the right by 2 units. Let me just use the calculator and show you how this will turn out. Now I don't know if you can see it. You might not be able to see it. Let me see. I don't think you can see it on my graphing calculator, so I'm going to go ahead and sketch it for you. This will be our old school method. So I'm going to try to be as precise as possible if I'm able to. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Just make it a little taller. So let me graph the original function of f of x. Original function f of x is 2x plus 5, which means is that we have an intercept of y equal to 5. 1, 2, 3, 4, 5. This is the point, right? And the slope is going 1, 2, going up 2, and going over 1. So I have a graph. I'm going to try to be as precise as possible if I'm able to do that. Okay, so this is our f of x equal to 2x plus 5. Now let's graph our inverse function. Our inverse function is at negative 2.5. So negative 2.5, 1, 2, 2.5, negative 2.5 is right here. Negative 2.5. And I'm going to go, as the slope is 1 over 2, so it go up 1 and over 1, 2. Hopefully this is precise enough. So right here, so these 2 points I'm going to connect. And this is our inverse function, f of x. In this case is 1/2 x minus 5/2. Now if you look at this, it turns out that it is precisely the mirror image along this 45-degree line, y equal to x. Y equal to x. And it's the mirror image. Mirror image. So this is a distinct property of inverse function. So we're going to test that out. We're going to test out this idea to see if indeed it is a mirror image. Inverse functions are a mirror image along y equal to x. Let's take a look at this. we just come up with f of x is equal to 2x plus phi, and its inverse to be 1/2 x minus phi half, right? This is what we just came up with. So let's take a look at the composite function f of inverse function. You remember we just had this lesson. That means we put the inverse function and put it into the original function and follow the rule of the original function. So in this case, we replace the inverse function with what inverse function actually stands for, which is in this case 1/2 x minus phi half. Now, f of something follows with 2 times that something plus phi. So instead of x, f of x equal to 2x plus phi, we have f of 1/2 x minus 1 phi half, what turns out to be replacing it with what's inside this x. So we end up with 2 times parenthesis 1/2 x minus phi half plus phi. Now, it is possible that you didn't follow me on this one. It could be confusing, I understand. Remember, f of x is equal to x plus phi. F of heart is equal to times heart plus phi. F of 1/2 x is equal to 2 times 1/2 x plus phi. F of 1/2 x minus phi half is equal to 2 times 1/2 x plus minus phi half plus phi. That's where I got it from. Okay? So that's where it is. So simplify, further along and simplify this. We have 2 times 1/2 x, right? 2 times 1/2 x minus 2 times phi half plus phi. 2 times 1/2 x is x minus phi plus phi. The answer is what? The answer is x. F of the inverse of its function turns out to be x. You put function and its inverse function and put them into each other, ends up to be x. And guess what? This x is precisely this graph right here. Is this 45-degree line that creates an image, a mirror image of one another. Likewise, if we say, well, if we do it the other direction, will it still work? Let me try it this way. I think I'm running out of page space. Let's take a look at this. If I were to say, well, what about if I have inverse function of the original function? What would happen? Well, the inverse function, let me write it down on below, because I like to make sure that they line up. F of x. Now remember f of x, let me just bring it back up a little bit. This way. Now f of x is 2x plus phi. So I will put 2x plus phi here. But 2x plus phi, now we're going to apply that into the inverse function. And the inverse function is 1/2 x minus phi half. So this whole thing goes into that little x. So it becomes, right, that becomes 1/2 times 2x plus phi minus phi half. And apply this in 1/2 times 2x plus 1/2 times phi minus phi half. I get x plus phi half minus phi half. What's the answer? X. That is a fascinating part of this property. So let's take advantage of the property and see what we can do with this. So in this case, example, if f of x is equal to 1/4 x plus 7 and g of x is equal to 4x minus 7, and the question is given to you is, are they inverse? Well, then what you do is first step is try to put f into g of x and see if it becomes x. If yes, then they are inverse to each other. If they don't equal to x, then they are not inverse to each other. So let's do that. So we got f of, now g will replace it with 4x minus 7. And then we put 4x minus 7 and apply that into f of x. So we end up with 1/4 4x minus 7 plus 7. We got 1/4 times 4x minus 1/4 times 7 plus 7. Guess what? This is x minus 7/4 plus 7. It does not equal to x. No, not inverse to each other. Okay, you got it? Now, next one. If f of x is equal to cube root of x minus 1, g of x is x cubed plus 1. Inverse? That's the question. Well, let's take a look at this. Let's try f of g of x. Well, in this case, right, f of g will replace it with x cubed plus 1. Now, what's inside here of the f? Put them all into the x. So we end up with cube root of x cubed plus 1 minus 1, right? Whatever this x is, we replace it with x cubed plus 1. So we end up with x cubed of x cube root of x cubed plus 1 minus 1. We end up with cube root of x cubed and is equal to x. Alright. Well, we should try it then the other way around and just to see if that also is true for g of f of x. Because if they are inverse to each other, it doesn't really matter which direction you input the function and the relations. So in this case, right, g of f of x and f of x, we replace it with what's defined over here, cube root of x minus 1. And now we take cube root of x minus 1 and put it all into this x right here for g, right? So we end up with cube root of x minus 1, the whole thing cube, then plus 1. We end up with x minus 1 plus 1, x. So then the answer is yes, inverse to each other. So recap, inverse function, how we find inverse function of a function or inverse relation of a function is to replace x for y and y for x, and then we solve for y. Second point, you should be able to graph the original function and the inverse function. And you should be able to see that they are the mirror image along the 45-degree straight line y equal to x. And then we also know that from the graph, it informs us to predict what the algebra will tell us, which is then if we have two equations or inverse relation to each other, then when you do the composite function of each other, either direction, you will end up with x, which makes complete sense. So if I would say, if someone would ask you and someone would say, hey, they give you a graph, and it may look, something like, let me see, what if the graph looked like, like this, and the question is sketch out a inverse relation of f of x. Well, you have an easy task here. What you do is create a 45-degree line, and then you turn the paper so you can kind of see it. You say, okay, how can I draw a mirror image along this? Now, it's not super accurate, but you get the point. Well, guess what? I bring it back out. This is my inverse function. Got it? So there's to it for this simple lesson. I'll see you later.